Okay, today's lesson is radical word problems. So I'm going to give you an example here. The perimeter of this rectangle is 16 centimeters. Find the value of this x. Okay, so I know perimeter is if of a rectangle, I add up all of these sides together, it's going to equal 16. So instead of going this plus this plus this plus this, I'm going to group them that I have 2 of these sides and 2 of those sides. Altogether, they're going to be 16. So how does that look in a math equation? 2 sides of 5 plus 2 sides of root x plus 1 altogether will equal 16. Okay, so that's step 1, making an equation. Now step 2 is solving. So I'm looking to isolate this radical, so I'm going to get rid of everything else in algebraic order. So this is really a value of 10, right? 2 times 5. So I'm going to get rid of that. Okay, so 2 root x plus 1 equals 6. Now I need to get rid of this 2 with the division. So root x plus 1 equals 3. Okay, so now I have the root isolated. How do I get rid of a square root? Opposite math operation. So I square. Squaring gets rid of the square root. So it's going to be x plus 1 equals 9. 3 squared is 9. Then I would subtract 1. X would be 8. Okay, always double check your answer. If this was 8, then this would be the square root of 9, which would be 3. This would be the square root of 9, which would be 3. So adding that up would be 6 plus 10, which is 16. All right, next problem. An object's velocity in meters per second is described by the formula, where mass is represented by m, and that's in kilograms, and E is representing kinetic energy in joules. If the mass of an object is 0.5 kg and the velocity is 40 meters per second, find the amount of kinetic energy. Okay, so this is what we're trying to find. Okay, so we're going to plug in V. We're going to replace with 40. And then I have the square root of all of this. 2e divided by the mass is 0.5. Okay, so on this side I can see that I actually have everything is inside the square root. So if I have a square root isolated, I square. Okay, so that cancels and I get 2e divided by 0.5, 40 squared on that side, so 1600. So how do I get e alone? Well, I get rid of the 0.5 first, so times by 0.5. So now 1600 times 0.5 is 800. Those cancel and you get 2e. Then I need to divide by 2 and I get 400 joules for the amount of kinetic energy. Okay, next question. In a thunderstorm, the wind velocity in meters per second can be described by this function. So V equals 5.7 times the root of 998 minus P, where P is the air pressure in millibars. What is the air pressure? So what is the air pressure? So I'm solving for P. What is the air pressure of a thunderstorm in which the wind velocity is 49.3? So this is going to be replaced in there. Okay, now 49.3 equals 5.7 times the root of 998 minus P. So I always look, do I have the root isolated? No. I need to divide. Okay, so once I do that, I get 8.6491 equals the square root of 998 minus P. Now I have the square root isolated, so to get rid of the root, I square. Okay, so on the left, 8.6491 squared, 74.807 equals, on the right, the root and square cancel, so I get 998 minus p. Okay, now to get p alone, let's move the 998 over. So subtract it, and you get negative 923.19. We can't forget that we have an actual negative in front of that p. So divide out the negative now. So the pressure is 923.19 millibars. Okay, next page. The number of seconds in the period of a pendulum is the length of time required for the pendulum to make one complete swing back and forth. Okay, so if you can think of like a grandfather clock, the hand always swings back and forth. So that's the period. So this is a formula given. T equals 2 pi times the root of L divided by 32 gives the period T for the pendulum of length L in feet. So this is the period of the pendulum. This is the length. So how long is this actual, let's say if it's a clock, grandfather clock. Okay, if Todd wants to build a grandfather clock with a pendulum that swings back and forth every 2 seconds, how long should it be? So therefore we know the T, the period is 2 seconds. Equals 2 pi, and then we don't know the length, divided by 32. Okay, so do we have the root isolated? No, the root is not all alone, so we need to get rid of the 2 pi. So I'm going to divide each side by 2 pi. Okay, 2 divided by 2 pi is a value of 0.318. Okay, now the root is isolated. How do I get rid of the root? I square. So I square that side. 0.318 squared is 0.1013. The square and square root cancel, so I get L divided by 32. So now I need L alone, so if it's divided by 32, I times by 32. So my final answer is 3.24 feet is the length of the pendulum in the clock. Okay, that is it for word problems.